It's time. Yes, today is about time. It's about how humans began measuring it, how we came to live our lives by it, and why it's structured the way it is in our current time. Welcome to Math Science History. I'm Gabrielle Burchak, and I have a background in math, science, and journalism. And today, we're going to take the time to learn about time. By the time you are done listening to today's podcast, you're going to know a lot more about time. So what time is it? Simple question, right? You probably glanced at your phone or your kitchen microwave. But what if I told you that the way we tell time, the ticking seconds, the 60-minute hours, the 24-hour day, the 7-day week, isn't natural at all? In fact, it's a patchwork of ancient customs, astronomy, politics, and religion. Long before clocks or calendars, humans observed the natural world. They followed the sun, the moon, and the seasons. These celestial cycles shaped their days, rituals, and migrations. But once agriculture emerged around 12,000 years ago, precision was no longer a luxury. It was survival. The story of timekeeping doesn't begin with grand temples or bronze mechanisms. It begins in the Fertile Crescent, where people first settled permanently nearly 12,000 years ago, around 10,000 BCE, in what we now call Mesopotamia. This was a region that was later divided among Sumeria, Acadia, Babylonia, and Assyria. Here, small farming communities began to emerge along the Tigris and Euphrates rivers. This was the Neolithic Revolution, when humans shifted from hunting and gathering to cultivating crops, domesticating animals, and building permanent homes. To plant, harvest, and store food successfully, these early settlers would have needed some construct of time. They likely watched the seasonal patterns of the sun and stars, marking cycles to guide their survival long before written history. Over thousands of years, these practical observations became sophisticated systems. By the Uruk period, which was between 4000 and 3100 BCE, Mesopotamian astronomers and priests had divided the sky into 12 equal zones, mapping the sun's annual journey through what we now know as the constellations of the zodiac. They also developed the sexagesimal system, or base 60 mathematics, still with us today in our 60 minutes and 60 seconds. These divisions allowed them to measure not just seasons, but smaller and smaller increments of time, blending astronomy, mathematics, and record-keeping into a structured worldview. Meanwhile, to the southwest, the civilization of ancient Egypt was taking place. Although Egypt's unification under a single ruler didn't occur until around 3100 BCE, their methods of timekeeping were equally ingenious. The Egyptians developed a 365-day calendar, dividing it into 12 months of 30 days, plus 5 epagomenal days dedicated to the gods. Using the heliacal rising of Sirius to predict the flooding of the Nile, they divided the day with shadow clocks and sundials and used star risings at night, similar in spirit to Mesopotamian deacons, to mark the passage of hours. Where Mesopotamia's genius gave us the mathematical skeleton of time, Egypt tied it to the sun's rhythm and the heartbeat of the Nile. Together, they laid the earliest foundations of the systems we still live by today. The Egyptians were among the first to formalize timekeeping, as we know. This could have also been formed during the age of the Aztecs, but we don't have writings to indicate so. At least I'm not aware of them yet. I will dig deeper into that. Their observations of the star Sirius rising just before dawn helped them predict the flooding of the Nile, a vital agricultural event. Ours? For that, we owe a debt to the Babylonians. The Greeks and the Romans later inherited this model. By the time Hipparchus introduced equinoctial hours, 12 equal parts for a day and night, regardless of season, the groundwork for our modern hour was laid. So why are there 60 seconds in a minute, 60 minutes in an hour, and 360 degrees in a circle? These numbers seem arbitrary, but they are not. They are part of an ancient system called sexagesimal, or base 60. And if you're interested in learning more about the sexagesimal system, I will put a link on our website to a podcast and blog that we did on the sexagesimal system. And while you're there, please remember to click on that coffee button and make a donation to Math Science History. Every donation that you make helps to keep our podcast up and running. We truly appreciate your generosity and are so grateful for the donations that we currently receive. So, the sexagesimal system originated out of Mesopotamia and was constructed by the Babylonians. The Babylonians lived over 4,000 years ago in Mesopotamia, modern-day Iraq. They inherited a powerful legacy from the Sumerians, and among their many achievements, those included writing, astronomy, and architecture. Among those was a sophisticated number system based on the number 60. Now, you might be wondering why 60? Why not something simpler like 10 or 100? Because we have 10 fingers and 10 times 10 is 100. Well, 60 is a supercomposite number, meaning it has more divisors than any smaller number. 60 can be evenly divided by 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. That makes it ideal for splitting things into parts, especially when you're trying to divide hours, angles, or even property in a way that's fair and flexible. So imagine trying to divide an hour into 2, 3, 4, or even 5 parts. 60 can handle that without messy reminders. But the sexagesimal system wasn't just about time. The Babylonians used it in astronomy, mathematics, and commerce. On their clay tablets, they recorded massive calculations, star charts, and even algebraic equations, all in base 60. And I know I've talked about this before, but one of their most famous tablets, the Plimpton 322, is over 3,000 years old and contains what we would now recognize as Pythagorean triples, suggesting they understood principles of right-angled triangles long before Pythagoras. And it was all written using a mix of base 60 for fractions and base 10 for counting whole numbers. Picture a hybrid system. They used a positional number system, meaning the place of a digit affected by its value, just like we do with tens, hundreds, and thousands. But theirs was way more advanced than what the Greeks and Romans had. And as a side note, if you're interested in reading about this, I go into deep detail in my book about Hypatia that you can find on Amazon. Yeah, I know I'm pushing a lot of stuff today, but I've been writing about this stuff for almost 15 years, and it really excites me. And so it's in my book on Hypatia. It's also on the blog, and it's in the podcast on my past episodes. So please do a deep dive into math science history and find some stuff about this. So back to the Greeks and the Romans and the Babylonians. The Babylonians had a kind of place value system more than 1,500 years before we adopted it with Arabic numerals. They even used a placeholder system that acted a bit like our modern zero, although it wasn't actually zero as we know it. So here's where things get interesting. Babylonian astronomers used this base 60 math to divide the circle into 360 degrees, probably because the circle was associated with the year. And there are roughly 360 days in a year if you round out the solar cycle. That division of the circle into 360 degrees stuck. And we still use it today in geometry, cartography, and navigation. Likewise, the Babylonian method of dividing time into 12 double hours for 24 hours total, with each hour split into 60 minutes and each minute split into 60 seconds, laid the groundwork for what became standard in Greek, Islamic, and later European astronomical traditions. Even though we now operate in a decimal-based society, our currency, our calculators, our computers, we've never really shaken off our Babylonian roots. Every time you glance at your watch, spin a compass, or measure an angle, you are whispering a thank you to the mathematicians of ancient Mesopotamia. So, yes, base 60 might seem odd today, especially if you're used to a clean simplicity of tens, But when it comes to dividing, measuring, and mapping the world, it turns out 60 is kind of a mathematical miracle. The Babylonians didn't just give us a clock. They gave us a worldview shaped by stars, logic, and timeless ingenuity. We'll be right back after a quick word from my advertisers. So now on to the early Roman calendar. It had only 10 months, beginning in March. That's why September means 7, but is our 9th month holiday. Their system didn't match the solar year and required constant tinkering. Basically, what happened is in 46 BCE, Julius Caesar enlisted Egyptian astronomers to fix the calendar. The new calendar was mostly for some positive Julius Caesar propaganda because he loved the propaganda, and also to assist his military in seasonal attacks. The Julian calendar served as a military guide. Still, the results helped to adjust the calendar in a more accurate form, and the result was the Julian calendar with 365 days with a leap year for every 4 years. It brought much needed stability. Still, even the Julian calendar ran about 11 minutes longer than the solar year. After centuries, that added up. As a quick side note, the Gregorian calendar was introduced in 1582 CE by Pope Gregory XIII as a reform of the Julian calendar. Its purpose was to correct the drift between the calendar year and the solar year caused by the Julian system's slightly inaccurate calculation of the year's length. The reform included adjusting the leap year rule, which states that if a year is divisible by 4, it is a leap year. But there's an exception to this. If it's also divisible by 100, it is not a leap year. There's also an exception to that exception. If it's divisible by 400, it is a leap year after all. So for the year 2000, if it's divisible by 400, it is a leap year. For the year 1900, divisible by 100 but not by 400, it is not a leap year. The year 2024, since it is divisible by 4 but not by 100, it is a leap year. This reform also realigned the calendar with the equinox by skipping 10 days in October 1582. But this really only applied to countries that adopted it immediately. And adoption was not instant. Catholic countries like Italy, Spain, and Portugal switched in 1582, but Protestant countries took decades or even centuries to adopt it. But we don't have time to talk about calendars. Let's talk about clocks. Before clocks, time was measured by the sky. People relied on natural rhythms, the sun rising and setting, the lengthening or shortening of days with the seasons, and the moon cycling through its phases. For thousands of years, these celestial patterns were enough. But as societies grew, rituals and responsibilities demanded something more precise, something measurable. The earliest timekeepers weren't mechanical at all. Think sundials, simple yet brilliant tools that use a shadow cast by a stick or a gnomon to tell the hour based on the sun's position in the sky. Ancient Egyptians used sundials as early as 1500 BCE, dividing daylight into 12 parts. But of course, these only worked on sunny days and not at night. So they built alternatives. Enter the water clock, or clepsydra, one of humanity's oldest time-measuring instruments. The earliest versions date back to ancient Babylon, Egypt, and China. These clocks worked by letting water drip from one vessel to another at a constant rate. As the water level rose or fell, it could be calibrated to measure time intervals. Water clocks allowed time to be tracked after sunset. This was an enormous leap in timekeeping. In medieval China, Susong's astronomical clock tower, built in 1090 CE, combined water-powered mechanisms with gears and wheels, early evidence of what would become clockwork machinery. In Europe, monks turned to candle clocks and incense clocks, which burned at predictable rates. These weren't precise by modern standards, but they were good enough for scheduling prayers. And that's the key. Early timekeeping wasn't for the general public. It was for religion, especially in Christian monasteries, where monks needed to observe the divine office, a daily schedule of prayers that happened at set hours throughout the day and night. As a result, monasteries became time's first official keepers. Now comes a game changer, the mechanical escapement. Around the late 13th to early 14th century, European inventors began creating devices that used weights, gears, and escapements to regulate movement. The escapement is what gave these machines their tick-tock rhythm. It allowed for energy to escape in controlled bursts, pushing gears forward at a regular rate, essentially dripping mechanical time instead of water. One of the earliest fully mechanical clocks was installed in Salisbury Cathedral, England, around 1386. It had no dial or hands, just a bell that rang at regular intervals. So, as a result, the first public clocks didn't show time, they sounded it. This made time a communal experience. Imagine a town square where everyone listens for the bell to signal a prayer, a meal, or the end of the workday. Time became a shared rhythm, no longer hidden in the stars or inside monasteries. And it also helped to structure society. But soon we wanted more than bells. We wanted to see time. In the 14th and 15th centuries, clockmakers began adding faces to their machines, often with only one hand, which was the hour hand. That was enough for daily life, which didn't demand minute-level precision. The minute hand came later, around the 16th century, as mechanisms became more refined. One of the most famous examples is the Prague astronomical clock installed in 1410. Not only did it tell the hour, but it also showed the position of the sun and moon, the zodiac signs, and it even included animated figures. Time wasn't just visible, it was theatrical. As cities were filled with public clocks, time became centralized. It shaped work, trade, governance, and daily structure. No longer was time something internal or intuitive. It was externalized, measured, and managed. By the 17th century, advances in metallurgy and precision engineering led to spring-powered watches, replacing weights and pendulums. The invention of the mainspring made clocks portable and personal. The next major leap came with Christian Huygens and the pendulum clock, patented in 1656. It was accurate to within 15 seconds per day, a stunning improvement at the time. Then came marine chronometers, essential for navigation at sea, thanks to John Harrison in the 18th century. These chronometers allowed sailors to calculate longitude with precision, revolutionizing global exploration. And just like that, time went from public towers to pocket watches, a symbol of sophistication and punctuality. By the 20th century, wristwatches became widespread, particularly during World War I, when soldiers needed easy access to the time without fumbling for a pocket watch. They could now just look at the time on their wrist. The personal clock was now standard. Everyone had their own little ticking universe. And then came the digital revolution. In 1927, the first quartz clock was developed. Quartz oscillates at a consistent frequency when electrified, allowing for astonishing accuracy. These clocks didn't rely on gears or pendulums, just electricity and crystal vibrations. By the 1970s, quartz wristwatches were mass-produced and affordable. The once elite instrument of kings and clergy became everyday tech. Today, we live by digital time. From our phones and computers to our microwaves and thermostats, we synchronize with atomic clocks, which count the vibrations of cesium atoms to define the second with unimaginable precision. What's most fascinating about atomic clocks is that they are so accurate that they only lose about 1 second every 100 million years. Ironically, though, as time has become more precise, it's also become more invisible. We don't watch clocks anymore. We get notifications. Our devices update automatically. Coordinated Universal Time, or UTC, governs everything from GPS satellites to stock markets to your smartwatch's alarm. The ticking is silent now, and the numbers are but aglow. But the bells, well, they have been replaced by a downloaded ringtone song, specifically with the best-selling ringtone song being T-Pain's I'm in Love with a Stripper. No joke. Behind that glowing screen lies the work of millennia. Every tick of your digital watch is the echo of water flowing in clay jars, of monks striking bells, and of astronomers charting the stars. Time became visible when we learned to mechanize it, to share it, to own it. And in doing so, we transformed how we work, think, and live. Today, we live literally in a different time world. Time is no longer a local affair because we now have time zones. And though it would make sense that we would have 24-hour time zones because there are 24 hours in a day, we actually have more time zones. So if you are interested in learning more about our time zones, stay tuned for this Friday's Flashcards episode. So let's fast forward to the 20th century. Einstein's theory of relativity showed that time isn't absolute. It changes depending on speed and gravity. Still, for everyday use, we needed consistency. In 1967, scientists defined the second using of the cesium-133 atom. Atomic clocks now measured 1 second as 9,192,631,770 oscillations of a cesium atom. These clocks run everything from GPS to financial markets. What this means is that when you check your phone, you are looking at atomic time. So why do we still live by 60-minute hours, 24-hour days, and 7-day weeks? In truth, it's less about logic and more about legacy. Once systems become embedded across cultures and continents, they become nearly impossible to unravel. Even revolutions, like the French attempt to decimalize time with the 10-hour days and the 100-minute hours, fail to uproot what tradition cements. We still wrestle with daylight savings time and leap seconds. But despite its quirks and contradictions, the structure we have inherited continues to shape our lives with remarkable endurance. Because time as we know it isn't something we discovered, it's something we created. From sundials casting shadows in the sand to atomic vibrations measured in billionths of a second, humanity has spent millennia sculpting meaning from the silent flow of existence. In shaping time, we shaped ourselves, our rituals, our civilizations, our sense of order. So, the next time you glance at the clock, remember, you're not just reading numbers. You are touching thousands of years of human curiosity, ingenuity, and tradition. You are synchronized with history, living in the same great continuum as the countless lives before you. And in that moment, the choice is yours to simply let time pass or to seize it. And that being said, carpe diem, my friends. Thank you for tuning in to Math Science History. If you enjoyed today's episode, please leave a quick rating and review. They really help the podcast. You can find our transcripts at mathsciencehistory.com. And while you're there, remember to click on that coffee button because every dollar you donate supports a portion of our production costs and keeps our educational website free. Again, thank you for tuning in. And until next time, carpe diem.